guys, so we finished the area unit, but we're not quite done. Now we're going to start talking about surface area. And the best way I can explain surface area is if you're trying to paint something, it's every single thing you can paint. So if you can get a little paintbrush to it and paint it, you have to paint it. So that's how I like to look at surface area. So this do now is actually a great do now to try. So it says a room 32 feet by 20 feet has a 10-foot high ceiling. How many square feet of surface must be painted to cover the walls and ceiling, but not the floor? So essentially we are painting everything but the floor. So let's just get a visual of what this could potentially look like. My drawings are not the best, but I will try my best. So here's our rectangular room. So we are painting everything, but we are not painting the floor. So now it says a room 32 feet by 20 feet by 10 feet. It really does not matter which one's the length, which one's the height, which one's the width. It truly doesn't matter as long as there's one number for each of them. So I'm going to say 32 by 20 by 10. Okay, so now let's go through and start painting. Now we're painting rectangles. So what I'm going to start doing is I'm going to paint this side rectangle right here. And how do we paint a rectangle? We know a rectangle is length by width. So that's like a sidewall. Let's call this sidewall. And that's 20 by 10. So that area is going to be 200. But aren't there two side walls that are the same? Like in a rectangular prism, the opposite sides are congruent. So this side wall has to be equal the surface area to this side wall. So we're going to say side walls will be 2 times 200, which is going to be 400. Okay, now let's talk about the front and back wall. Let's talk about the front and back wall. Well, we know the base of this front and back wall is 32. I need the height. Well, in a rectangle, aren't opposite sides congruent? So if that back side is 10, this front side is also 10. So we'll say front wall. So we are going to say front wall. We're going to have 32 base, a 10 height, which is 320. But isn't the front and back wall, aren't they congruent? So we'll say front and back. So we're going to say 2 times 320, which is going to be 640. Now, we are not painting the floor, but we are painting the ceiling. So let me highlight that ceiling. Here's the ceiling that we're painting. Now I need my base and my height for this rectangle. Well, the base is going to be the same base as the bottom, so that's going to be 32. And the height is going to be here. So this bottom part of the rectangle is 20, the top part is also 20. So we are a 32 by 20 rectangle. So we are talking about the ceiling right now. We are 32 by 20. So that's going to be 640. And now what are we going to do with all these? We're going to just add them right up. So we are 400 plus 640 plus 640. So the surface area, which I write as SA, surface area is going to be, 640, is going to be 1,680 feet squared. All right, let's get into the lesson. I can erase this do now. Okay, so we are getting to surface area of prisms. Solids with flat faces are called polyhedra, meaning many faces. The faces are polygons and the lines where they intersect are called edges. One familiar type of polyhedron is the prism. So remember, we name a prism by its bases. So this is called a rectangular prism. Here, the bases are triangle, so it's called a triangular prism. Here, the bases are hexagon, so this is called a hexagonal prism. Every prism has two congruent parallel faces. Every prism has two congruent parallel faces called bases. So let's just turn the page one more time. If you look at this, here the triangles, those are called the bases. And these two triangles not only have to be parallel, meaning they'll never touch, but they also have to be congruent. In the hexagonal prism, these hexagons not only have to be parallel, but they also have to be congruent, the one on top, one on bottom. A set of parallel edges that connect corresponding vertices of the two parallel faces. The parallel edges joining the vertices of the bases are called lateral edges, and I'll explain all this in the picture below. The faces of the prisms that are not bases are called lateral faces. The lateral faces of all prisms are parallelograms. So therefore, we name a prism by their face. A prism with a hexagonal face is called a hexagonal prism. So right now I have everything laid out for you. So this is a triangular prism, obviously. The bases are triangles. These triangles not only are parallel, but they're also congruent. Now, all these middle parts are parallelograms. The side that makes up these parallelograms are called lateral edges, and the actual parallelogram itself is called a lateral face. Okay, so we're going to have two types of surface area, basic types of surface area. The lateral area versus the total area. The lateral surface area means everything but no bases. So lateral area means no bases. And the total surface area is exactly what it says. It's everything. It's the lateral and the bases. It's everything. Now, this is going to be a huge thing. We put the word right in front of the name prism. For example, a right triangular prism. A right triangular prism doesn't mean that our triangle is a right triangle. Not at all. What it does mean is that our parallelograms now have right angles. And what is a parallelogram with right angles? It is a rectangle. So this is going to be huge because most of the prisms we're going to be dealing with are going to be right. In the textbook, sometimes it uses the word box to represent right. It just means that the faces are now rectangles. The lateral faces are now rectangles. So let's turn the page and do some sample problems. It says given right triangular prism. Now that word right is a huge thing for us. The right does not mean the triangle's a right triangle. That right now means that all those lateral faces are rectangles. So we want to first find the lateral area. Lateral area means no bases. Lateral area is no bases. So what we want to do is, what are we going to paint? Okay, so we're going to paint everything but the bases. So we're going to paint the two rectangles. They're both the two sides. And then we could turn it over and paint the floor, right? Right, so surface area is everything you can paint without dismantling the figure. Okay? Everything you can paint without dismantling the figure. So I'm going to paint the triangle. So the lateral area is going to equal area of three, not triangles, sorry, rectangles. And I know they're rectangles, not parallelograms, because it has the word right there. So where do we want to start? Let's start with this front rectangle. Call it rectangle 1, area of rectangle 1. All right, so area of rectangles, base times height. So we are 20 by 15. So we're going to multiply 20 times 15, and we are going to get 300. Now let's find the area of the next rectangle. So that I will call that the back rectangle back here. Now these two rectangles sort of making that TP, they're not congruent. Even though both their bases are 20, this height is 13. So we're going to do 20 times 13, which is 260. Now what we're going to do, remember, we're not dismantling the figure. We're going to take this little triangular prism, turn it upside down, and paint that bottom base. So that bottom base we'll call area 3, area of rectangle 3. We know the height is 14 and the base will be 20, the same as here. So we are 20 times 14, which is going to be 280. So now what we're going to do, the lateral area is going to be everything added together. So we're 300 plus 260 plus 280. So the lateral area is going to be 840 units squared. All right, so that was part A. So now we want to find part B. We want to find the total area. Well, the total area is going to be everything, including the bases. Well, we just found the lateral area. There's no need to do all that calculations over. So we're going to do the lateral area plus 2 times the area of the base. Because these bases are congruent, I just need to find the area of one base and then multiply by 2. Well, the lateral area we said was 840. We figured that out. So then we're going to do plus 2 times half the base times the height of the triangle. Well, this half and this 2 cancel out. So we are literally just base times height. So our base is 14. Our height is not 13. Remember, a height has to be made with a right angle. So our height is 12. So we're going to say 840 plus 14 times 12, which is going to be 168. 840 plus 168 is going to be 1,008 units squared. Okay, next one. Find the total surface area of a right rectangular prism with a length of 15 centimeters, a width of 5 centimeters, and a height of 10 centimeters. Because it says right, all the middle figures are rectangles, not parallelograms. So we're talking about a right rectangular prism. All right, so how many rectangles are we painting? 1, 2, 3, 4, 5, 6. But what's great about this is that the top and bottom will be the same, the left and right will be the same, the front and back will be the same. So let's write down our dimensions. So we are 15 by 5 by 10. There we go. All right, so let's find the front and back. Or let's find the side walls. Let's do that, side walls. So we're going to say 2 times, because there's 2 walls, 1, 2, and then we have 5 times 10. So we're 2 times 50, which is going to be 100. Let's figure out the top, ceiling, and floor. So that's going to be 2 times 5 times 15, which is 75. 2 times 75 is going to be 150. And then last but not least, we have front and back. That's going to be 2 times, let's see, this base is 15, and the height has to be the same height as this, which is 10. So we are 15 times 10, which is 150 times 2 is 300. So the total area is going to be all of these added together, which it will be 550 centimeters squared. Okay, so this last problem, find the lateral area. Remember, lateral area means no bases. I want you to do this by yourself, so pause me and then check your answer when you're done. So you're doing the lateral area, no bases, so you're finding the area of 3 different rectangles, 3 different rectangles, and adding them together. And what you should get is a lateral area of 150 units squared. All right, next page. Okay, surface area of pyramids. All right, so there are some keywords that we need to know about pyramids, which we've talked about before. I'll just refresh your memory. A pyramid has only one base. Its lateral edges are not parallel but meet at a single point called the vertex. The base may be any type of polygon, but the lateral faces must always be triangles. A pyramid is named by its base. A regular pyramid has a regular polygon as its base and also has congruent lateral edges. That makes these lateral faces of the regular pyramid congruent isosceles triangles. So if my base is a regular figure like a square or like an equilateral triangle, those are regular, meaning equiangular, equilateral, then all these triangle faces are actually congruent. All the triangle faces are congruent. Okay, some key vocabulary you need to remember. The altitude of a pyramid starts at the vertex, connects to the middle of the base, and makes a right angle. Okay, the sides that make up the triangles are called lateral edges. And the slant height is not an altitude of the pyramid, it's an altitude of one of the faces, and it's also bisects that face at that bottom side. All right, let's jump right in. The regular pyramid shown, this is huge. It makes our lives so much easier. Why is it so much easier? It means that all these triangles are congruent, and the base has to be a regular figure. So the lateral edge is 10. That means all the sides of the triangles, all the legs of the triangles have to be 10. The base has a side length of 12. We want to first find the lateral area and then the total area. Well, remember, lateral area means no base. So we are going to find the area of 3 triangles, but all 3 of these triangles, not 3, 1, 2, 3, 4 triangles. Sorry, we want to find the area of 4 triangles, but all of these triangles are congruent. So lateral area is going to equal 4 times the area of a triangle. So that's going to be 4 times half the base times the height. Well, the base of the triangle is 12. The height is not 10. Remember, the height has to be made with a right angle. So we need to find that height. Remember the slant height breaks that down into 6 and 6. I'm looking at this side right triangle. I'll highlight it in yellow. I'm looking at this right now. This is absolutely a triple times 2. So if you divide by 2, it's a 3 and a 5. So it's a 3, 4, 5. Multiply back by 2, it's an 8. So the lateral area, this 4 becomes a 2. So we're going to have 2 times the base, which is 12, and the height, which is 8. And we are going to get 192 units squared for the lateral area. Now we want to find the total area. Well, remember the total area is going to be the lateral area plus the area of the base. So the lateral area, we figured out is 192. Now, because this is a regular pyramid, that quadrilateral has to be a square. The only quadrilateral that's equilateral and equiangular is a square. So plus the area of the square. So we're 192 plus 12 squared. So we are 192 plus 144, which is 336 units squared. Okay, so now this next one is going to be a little bit tedious, just warning you. The base of a rectangular pyramid A, B, C, D, E is 10 by 12. The altitude is 12, the lateral edges are congruent. All right, the base of this rectangular pyramid. That means this pyramid's base is a rectangle. Is a rectangle regular? No, a rectangle is not regular. So that means these triangles, 4 triangles, the lateral faces are not all congruent. But some of them are congruent. Which ones are congruent? The ones that are across from each other are the ones that are congruent. Okay, so we need to, is A, B, C, D, E regular? No, because the base is not regular. Right, now we want to find the total area. So let's go through this. So the total area, let's come up with our game plan. The total area is going to be, let's talk about the front slash back plus left slash right plus base. There we go. So that's what we're going to do. The area of the front slash back plus the area of the left slash right and the area of the base. Okay, so let's look at the front and back. So here's my triangle. Our base is clearly 18, but I need a height. So it's saying the altitude of the pyramid is 12. So now I know where we're looking. So I'm going to highlight this. The altitude of this pyramid is 12. Now remember, the altitude connects midway. So from B to C is 10. So from the middle to H has to be 5. This is a triple of 5, 12, 13. So now we know for the front and back, we're going to do 2 times the base is 18, the height is 13. I'm sorry, half. 2 times half, the base times the height. This 2 halves, the half and the 2 cancel out, so we're left with 18 times 13, which is going to be 234. So now we need plus the left and the right, so it's going to be half, oh sorry, not half, plus 2 times half the base times the height of the left and right. So now our base is clearly 10, but we need to find our height. So I'm going to use the altitude again. The altitude connects to the midpoint. So instead of now this length is 18, so halfway across will be 9. And this is, what was the altitude? 12. So this is a triple times 3, a 9, 12, 15. So the height is 15. So we're half. The base is 10. The height is 15. The half and the 2 cancel out. So we are plus 150. And now we need the area of the base, which is just a rectangle. So that's 10 times 18, base times height. So plus 180. If you add these all up, we are going to get 564 units squared. Okay, so the regular pyramid has a slant height of 12, a lateral edge of 15. Find all of this stuff. This is what I want you to do this one all by yourself. Pause me and then come back to watch. So it says that we are a regular pyramid. it says it has a slant height of 12, so this is 12, a lateral edge of 15. Find the perimeter of the base, find the lateral area, the area of the base, and then the total area. Okay, step by step. First, I need to find out what the length of one of the bases is. So right here, this is actually a triple times 3. If you divide by 3, you have a 4 and a 5. So it's a 3, 4, 5 times back by 3. This is 9, which means this is 9, which means one side of the base is 18. Because this is regular, we know the base is a square. So we are 18 squared, which is going to be 324 units squared. So that's the area of the base. Now we want to find the lateral area. Well, remember the lateral area, because it's regular, all 4 of these triangles are congruent. So it's 4 times the area of triangle. The half and the 4 will multiply down to 2. So we're 2 times base times height. Look at the triangle. The base is 18. The height of this triangle is 12. So we are going to get 432 units squared for the lateral area. Now they want the area of the base. Well, the area of the base is just a square. So the area of the base is going to be 18 squared, which is 324. Sorry, guys. I wrote the area for the perimeter. The area of the square, let's go back to that first part, is going to be 4 times 18. Perimeter, just add up all the sides, right? So 4 times 18 will be 72. Oh, sorry about that. Units, not units squared. The area will be units squared. And now the total area, so we got 324 for the area of the base. Now let me erase to make some more room. Now the total area is really just the lateral area plus the area of the base. Total area equals lateral area plus area of the base. So the total area is going to be 432 plus 324, which is 756 units squared. All right, we are done for today's lesson. Have a great day.